Hey everybody, Miss Dietrich here. We're taking a look at question number 6 from 5.4. There are 32 students in Mr. Moreno's class and 62 and 5/10% of the students are girls. How many boys are in the class? Now recall that in class we talked about how if you take the all of it number and you multiply it by your favorite equivalent of the percent, that will get you the part. Well, if we take a look at the algorithm for this is the all of it number, and we're multiplying it by our favorite equivalent of this, because if we were going to change this to a decimal, we would move it 2 to the left. So that's shown here. The product of that would end up being 20. Now you would have to ask yourself, 20 what? Does this represent the girls, or does it represent the boys? Because they want to know the boys. Now if this is the chunk that would be girls, then that means that the balance of it would be boys. So in order to find that, we would have to subtract the 20 from the 32, because remember this is girls, to get the boys, and if we subtract, then we end up getting 12. Now that's a little complicated to remember, because a lot of people just put 20 and think on this answer space and think they're done. So a better approach is to do something called make a bar diagram. So let me find one that I have in here where I set up the bar. Let's see. Let's look at this one. A jar contains 125 marbles. Given that 4% of the marbles are green, 60% are blue, and the rest are red, how many red marbles are in the jar? So when you're using this idea of a double, we call this a tape diagram or a bar model, I like to have one of the bars be talking about the percent and the other one be talking about the actual quantity of marbles. Now remember, in the percent world, if you have all of it, you have 100%. So I'm just going to put that up here. Now we're talking about 60% and 4%. So let's just kind of chunk things up. So given that 4% of the marbles are green, so that's not very many. If we were to just kind of ballpark what that might look like, that's a small percentage. So 4%, I'm just going to write that here, and we can put somewhere green. Let's put green underneath. Green. All right, and then they're talking about 60% of the marbles are blue. So I think I'm going to work backwards, because if we were at the halfway mark, it would be here. So let's make this chunk right here. Let's make that chunk blue. So that's 60% for that chunk. 60%, and let's put in, those are blue. Now that means that this chunk in here would be the rest, right? This chunk, which they're talking about that being red. So let's put red. Now, are you able to see what the percent would be? Because so far we've used up 64%, and we would have to subtract 64% from 100 to get the percent. So let's see what that would look like. So this would become a 0. This is a 10 temporarily. Make that a 9 so that this can become a 10. 10 minus 4 is 6, and this minus 6 is 3. So 36% are red. Now we need to know the actual quantities. So the all of it number, we're going to put that over here. There's 125 marbles in the jar. And they're interested in how many red marbles are in the jar. So we need this number right here, the red number. Now, if we know that that's 36% of the 125 marbles, that means we can think about our favorite decimal equivalent of this, which would be 36 hundredths, and we can multiply that decimal equivalent with the all of it number. So in other words, take 125 and multiply it by 36 hundredths. And when you finish that algorithm, that's going to be how many are red. And if you needed to find the green and the blue, then you would take 4% of 125 to get the green. You would take 60% or 0.6 times 125 to get the blue. But fortunately, they didn't ask for that. They only wanted this number. All right, so finish up the algorithm, and you'll have the answer.